BF Day proudly presents Mr. M's Math Games and Math Breakthroughs.
Hello everybody and welcome to episode 10 of Mr. M's Math Games and Math Breakthroughs. I am so excited to see you. It's been a while since we had one of these videos and I have a special treat for you today. So instead of playing a math game, we're actually going to learn the science and math of snowflakes. That'll be our first video. And then the second video, we're going to have Mark Robert, who is a very famous YouTuber who does a bunch of science experiments. He's going to try to see if three things from three different holiday movies are actually true. So there's going to be one about the Home Alone, there's going to be one about Elf, and another one about the Christmas Story. So I hope you enjoy those two videos. And then there won't be a Flipgrid assignment for this episode. Instead, if you haven't finished your Estimation 180 project, make sure to do that this week. It is due on Friday, so I would use the time for today to make sure that you are working on that project. So good luck, and I will see you tomorrow. Enjoy the videos.
If you ever find yourself gazing at falling snow, why not catch a few snowflakes on your glove and examine their shapes? You might notice that they look symmetrical, and if you look closely, you'll see they have 6 sides. You could say a snowflake is simply frozen water, but compare one with an ice cube from the freezer, and you'll realize they're very different things. Unlike ice cubes, formed when liquid freezes into a solid, snowflakes form when water vapor turns straight into ice. But that still doesn't explain why snowflakes have 6 sides. To understand that, we need to delve deeper into the physics of water. Water is made out of 2 hydrogen atoms and 1 oxygen atom. A single water molecule thus has 10 protons and 10 electrons, 8 from oxygen and 1 from each hydrogen atom. The 2 electrons from oxygen's outer shell are shared with 2 electrons from both hydrogens as they bond together, and the remaining 4 outer shell electrons from oxygen form 2 pairs. We call the bonds between these atoms covalent bonds. The pairs of electrons are all negatively charged. Similar charges repel, so they tend to stay as far away from each other as possible. The pairs form 4 electron clouds, 2 of which are where the hydrogen and oxygen share electrons. The repulsion between the unbonded pairs is even stronger than repulsion between the shared pairs. So the 2 hydrogens get pushed a little further to an angle of 104.5 degrees. The water molecule as a whole is electrically neutral, but oxygen gets a larger share of electrons, making it slightly negative and the hydrogens slightly positive. Due to its negative charge, the oxygen in one molecule is attracted to the positive charge of the hydrogen in another molecule. And so a weak bond between the 2 molecules, called a hydrogen bond, is formed. When water freezes, this bonding occurs on repeat, ultimately forming a hexagonal structure due to the angle between hydrogens and oxygen within each molecule. This is the seed of a snowflake, and it retains a hexagonal shape as it grows. As the snowflake moves through the air, water vapor molecules stick to the 6 sharp edges and expand the snowflake outwards, bit by bit. A snowflake's developing shape depends on atmospheric conditions like humidity and temperature. As a snowflake falls, changes in weather conditions can affect how it grows, and even small differences in the paths 2 snowflakes take will differentiate their shapes. However, since conditions at the 6 sharp edges of one snowflake are similar, a symmetric snowflake can grow. Weather conditions affect snow on the ground as well. Warmer ground temperatures produce a wetter snow that is easier to pack because liquid water molecules help snowflakes stick to each other. Melted snow also plays a critical role in another wintry activity, skiing. Completely dry snow is very difficult to ski on because there's too much friction between the jagged snowflakes and the ski surface. So what's happening is that as skis move, they rub the surface of the snow and warm it up, creating a thin layer of water, which helps them slide along. So technically, it's not really snow skiing, but water skiing. But it is true that no matter how hard you look, you're almost definitely not going to find 2 identical snowflakes. And that's a mystery that scientists are still trying to solve, though we know that it has to do with the many possible branching points in snowflake formation and the differences in temperature and humidity. And while we wait for the answer, we can enjoy watching these tiny fractals falling from the sky.
I'm Mark.
Hey, Vsauce, I'm Jake.
And today we are in a replica of the Home Alone house that Jake built with his very own hands. So as thorough men of science, we have set up a few experiments to test some questionable scenes from a few Christmas classics. First, from A Christmas Story, if you can really shoot your eye out with a Red Ryder BB gun. And then from Elf, what happens if you actually get hit with a snowball at 95 miles an hour? And finally from Home Alone, what happens if you get a blowtorch on your head for 7 seconds? Not yet, Jake.
No?
Yeah.
Oh.
And these will be the first time that we're running these tests, so we truly don't know what's going to happen. But as firm believers in the scientific method, we're going to test our hypotheses and then see who is closer to the final result. And the winner gets to keep the leg lamp behind us.
What happens to the loser?
The loser has to wear Ralphie's pink bunny suit.
Ooh, yeah.
You ready to do this?
Yes, let's do it.
Let's go. So in the movie A Christmas Story, all Ralphie wants for Christmas is a Red Ryder BB gun. But all the adults in his life keep saying no because they say,
"You'll shoot your eye out, kid."
what do you think, Jake?
I do think that they're not talking about his eye actually coming out, because you have the optic nerve in there, which is about as thick as your pinky. I think they really mean that the BB is going to penetrate the eye and then he'll go blind, which no one wants.
Nobody wants
No one
that.
wants
And that seems like a legitimate concern, right? And because they say they'll shoot his own eye out, ostensibly that means he shoots, the BB goes out, bounces off something, and hits his own eye. So to test this out, we have an authentic Red Ryder BB gun, and since Jake wouldn't volunteer,
Sorry about that.
I had to find some cow eyes that they use for like biology classes and dissection. And so as a control, we're gonna make sure the BB will penetrate the eye first without even bouncing off anything. All right, so that went straight through. There's like no issues. The real question though is the ricochet, right? That's true to the movie. So on this next one, we're gonna have the BB come straight, it'll hit the steel plate and then bounce into the eye. So will it make it through the eye?
I think yes. I mean, as you said, it had so much energy, it went all the way through the eye. I think it'll hit the plate, ricochet off, go right into the eye, no problem.
I think it's gonna hit the plate, it's gonna like put a dent in it, it will lose a bunch of energy, it'll hit the eye but won't actually penetrate it.
Okay.
So take a moment to guess in the comments below who's right, me or Jake, but probably me, and let's check it out.
Yeah, let's do it.
Totally didn't go through. It is interesting though, you can see the dent in the plate, right? I think that was the culprit.
Oh, totally. And also you could see how much energy the eye absorbed. It was, yeah, I don't know. I think it was rigged.
It's a fair point though. A cow eye is definitely thicker than a human eye. So if that were Ralphie, that's bad news,
Yeah.
right? Like 500,000 people a year lose their eyesight due to like eye injuries. So eye protection is definitely important, but most importantly, I won this challenge. Okay, so I'm up 1-0, heading into round 2. So in the movie Elf, Buddy is sort of screwing up a bunch of things in the big city and nobody likes him. But then his brother gets attacked by some thugs in Central Park and he shows off his mad elf skills. So I did some investigating and I found the spot in Central Park where this actually occurred. And then I measured the distance and then I also watched the video back and looked how many frames it took and then calculated the velocity of the snowballs. Turns out they are thrown at 95 miles an hour.
Oh my gosh.
And yet, the punks like don't even move at all. So the question for round 2 is would you fall backwards if you got hit by a snowball at 95 miles an hour?
I would say no. I think you might stumble backwards a little bit, but it's not going to knock you flat on the ground.
And I disagree. 95 miles an hour is very fast. And I think if that comes at your chest, you're gonna move and stumble back, unlike the punks in the video.
But how are we going to get a snowball going 95 miles per hour?
That's a great question, and I don't know the answer to it. I originally wanted to use my snowball machine gun, but that tops out at like 40 miles an hour.
Yeah, not good enough.
Luckily, it turns out if you do the math, that a softball traveling at 65 miles an hour will push you back just as much as a snowball traveling at 95 miles an hour. And that's because they have the same momentum, which is defined as the weight of something multiplied by how fast it's going. So since a softball weighs a bit more, it needs to be traveling a little bit slower to have the same like pushback or momentum transfer to you. And thankfully, I have a way to make a softball go 65 miles an hour.
Awesome.
You ready to get suited up?
What? Why?
Oh, you lost the first round, so losers always.
But no.
Yeah.
We don't have to do this. That's fine.
You lost. 3, 2, 1. It looks like the softball pushed Jake back slightly, but not near as much as I hypothesized. So that means we're all tied up, headed into the final round. So in the movie Home Alone, Kevin is defending his house from the wet bandits with all these amazing homemade booby traps, which we actually made a video of that on Jake's channel, Vsauce3, so you should go check that out. One of these booby traps is in the kitchen, so when Joe Pesci walks in, the blowtorch goes off with like 4,000 degree Fahrenheit heat, and he just sits there and takes it for 7 seconds, after which he runs with his head on fire for an additional 4 seconds and plunges his head in the snow. And in the end, this is what the damage looks like.
I, don't think that is realistic at all.
I agree, that seems like an underrepresentation of the damage that would have been done. So to test this out, the good news is we actually have a volunteer.
Oh, that's lovely.
So underneath this beanie is a layer of chicken skin, and then I've drilled into the foam head about 2 inches down and put a BB. So the question is, do we think the heat is hot enough to burn through the beanie, through the skin, and then 2 inches down into the head?
I think, yes, given the duration of time and the amount of heat, it's gonna be pretty severe.
It's a bold claim. I don't think it will actually get all the way down there. All right, well let's check it out. Now it's time. After filming this video, I was curious, so I talked with a couple expert surgeons from the Arizona Burn Center, and they told me that if this actually happened to you, in less than a second, you would have a 3rd-degree burn. And they said that the chicken was a good representation for the skin covering your skull, and it would take between 2 to 3 seconds to burn through that down to the bone. At that point, you've still got 8 seconds left, and your skull would protect your brain so it wouldn't be fatal, but it would be so damaged that you'd probably need skull reconstruction to replace the charred portion, and that carries with it complications that can be fatal. Moment of truth.
Let's see.
This doesn't look like it's gonna... Ah,
yes!
There it is!
Oh man, okay, so the BB is exposed.
Very exposed. Curse you! So a disappointingly hearty congratulations to Jake for winning. He gets to keep the amazing leg lamp.